We would like to find the first and last position of some element in a sorted array. So we have a sorted array and a target that we'd like to locate. If you look at example 1, we have target 8, so that means that the first and last time that 8 appears is at index 3 and index 4. So the way we're going to solve this is by leveraging a very important property of this array is that it's already sorted. So if you haven't noticed already, we're going to want to use binary search. So first, let's take the length of nums. Let's write up our binary search function, rv, and the way that's going to work is by saying, well, okay, we have low and high equals 0, and len of r minus 1, and then we'll say while low is less than or equal to high, mid equals low plus high over 2, floor division, right? Then we say if r of mid equals v, then we have found our integer in that sorted array. We want to return mid. And then we'll say if r of mid is less than v, low equals mid plus 1. Low equals mid plus 1 because we're below our target in the array. And of course we have if r of mid is greater than v, then we have high equals mid minus 1. And then we update mid, so mid equals low plus high, floor division over 2, and we continue to run that algorithm until we've located our integer or the element we're looking for. Otherwise, we will return -1. Okay, so what we want to do next is locate that integer. So we say I equals bin search of nums and target. So that'll be our R and V. Okay, if I is -1, then we want to return -1 because that's what is required in the prompt if the target's not in the array. Otherwise, what we want to do is jk equals I and I. Now, here's what we're going to do. We'll say while j is greater than or equal to 0, if nums of j is not equal to target, break. The reason we're going to do that, we want to find the leftmost occurrence for our integer under consideration. So we continue to decrement j by 1 until we've found the last time that our element appears in the array. And of course, as you can expect, we're going to do the same thing, similar type of logic rather, for the right. We want to send k off until we've located the rightmost instance of our integer. So we'll say if nums of k not equal to target, break. In the event that that does not pass, then we say k plus equals 1. And then of course we have to handle the overshooting, and we say j plus equals 1, k minus equals 1 because it will be overshot by 1 in both directions. Then finally we return an array of j and k, which is the leftmost and rightmost occurrence of the element in the sorted array. We run, accepted, submit, outstanding.